Hi everyone, this is Mr. Jolliffe here for our next video in the week 2 series. Sorry this looks a little funny, I am recording from my iPad, um, mostly because the video from last year had a boo-boo, so I'm correcting on the go. Uh, this video is on calculating the mean, expected value, and standard deviation for a discrete probability distribution. So our video from last time covered what a probability distribution was for discrete random variable. Now we're going to talk about how to find the mean and standard deviation. The expected value is the long-term average or the mean for the probability distribution. So in this class, we're going to use those two values or two words interchangeably when we talk about probability distributions. The long-term average is kind of important here. What we mean when we say long-term average is we repeat the probability experiment over and over and over and over again, and we record the results. And if we were to average those results over a large number of times, we would expect to see that mean or that average. For example, if I'm flipping coins, so I'm flipping a penny as heads or tails, and I'm recording the number of or proportion of heads that I get, I expect that if I flip a coin over and over and over and over again for a really long period of time, half my outcomes are going to be heads. That's the long-term average or the mean for that probability distribution. We calculate it really similar to how we calculate the mean for grouped data, and we saw that in week 1. So in week 1, to calculate that mean for grouped data, we would multiply the midpoint times the frequency and divide by the total frequency. Well, frequency divided by total frequency is just relative frequency. It's a decimal. So it was midpoint times a decimal. We're going to do that same idea here. We're just going to add up the x value, the outcome, times its probability, which is the number of ways we get that outcome divided by the total number of outcomes. So probability distributions behave really similar to grouped frequency tables. That means you can actually find the expected value or mean and the standard deviation the same way you do for group frequency tables using your TI-84 calculator. The only difference is if you do this for a probability distribution, you'll notice that the TI-84 will only give you a population standard deviation. The calculator recognizes that it's a probability distribution, and so it's a population value instead of a sample value. We're going to go ahead and do an example so you can see how to calculate the expected value, and then we'll talk about standard deviation. So for our example, a men's soccer team plays soccer 0, 1, or 2 days a week. The probability that they play 0 days is 0.2. The probability that they play 1 day is 0.5. And the probability that they play 2 days is 0.3. Find the expected value of the number of days per week the men's soccer team plays soccer. So first step, we weren't given a table. We should make a table. So let's make our probability distribution. We have a column for x, which are the possible outcomes, 0 days, 1 day, 2 days. And we have a column for p of x, the probability that they play that number of days per week, 0.2, 0.5, 0.3. Next, we're going to add a column for our calculation. We know we have to multiply x times p of x. So we're going to go ahead and do that. 0 times 0.2 is 0.2, 1 times 0.5 is 0.5, and 2 times 0.3 is 0.6. The next step, our formula says, just add those values together. So if we add down that last column, 0 plus 0.5 plus 0.6, gives us an expected value of 1.1 days per week. So if we were to look at the number of days per week that this soccer team played over a long period of time, we'd expect an average of 1.1 days per week. Last week, we learned that that measure of center, where the middle of your distribution is not the only important information. We can have two distributions that look wildly different that have the same mean. So in order to get a complete picture of a data set, we need to know what the spread looks like. How spread out is that data about the mean? And one of the measures we use to do that is standard deviation. To calculate the standard deviation for a probability distribution, the formula is going to look a little different. Again, if you're doing this on your calculator, it's going to work just like it did for a frequency table. But if you're doing it by hand, the formula looks weird. And so we're going to use that data table to help us. We're going to add a column for x minus the mean squared times p of x. So we're adding a fourth column to our table. We fill that column in using the equation. And just like for the mean, we're going to add down that column. The only difference is this doesn't give us the standard deviation. This gives us the variance. To get the standard deviation, we have to take the square root of the variance. The formula, which looks a little scary, is that our standard deviation sigma is the square root of the sum of x minus e of x squared times p of x. And again, scary, particularly if you're not used to math notation. But that formula is exactly what those 4 steps in the data table walk us through. So let's go ahead and do that using that data table from our last example. So we're still looking at the men's soccer team. We have our probability distribution set up. Now we're going to add another column for the x minus ex squared times p of x. Maybe, there we go. Then we're going to use that formula to calculate the values that go into those boxes. And I do that in the space below the table just because I didn't have room in the table. You can do this directly in the table if you want. So 0, which is our x value, minus our expected value, 1.1. We square that, and then we multiply by 0.2, and that's going to give us 2.42. We repeat for x is 1 and x is 2, and we get those 3 values shown on your screen. We plug them back into our table, nice and pretty. And then step 3 says, add down that new column. So we're going to add those 3 values together, and that gives us 0.49. That value is our variance. That's the standard deviation squared. To get our final answer, we have to take the square root. So the square root of 0.49 is 0.7. So for this probability distribution of the number of days that the men's soccer team plays per week, the mean is 1.1 days per week, and the standard deviation, or the average spread about that mean, is 0.7 days per week. Okay, what I'd like you to do is grab a calculator if you don't have one already, and I'm going to put another example up here that I'd like you to try on your own. So for this, try it. A hospital researcher is interested in the number of times the average post-op patient will ring the nurse during a 12-hour shift. For a random sample of 50 patients, the following information was obtained. What is the expected value? What is the standard deviation? So on a sheet of scratch paper or using your TI-84, go ahead and calculate that expected value or standard deviation. So go ahead and pause this video. I'm going to hang on for just a second. And when you come back, I'll have the answers on the screen. And then we will be done. Okay, so I'm assuming that you've, on a piece of scratch paper, done these already. So let's go ahead and look. When I did this, I got an expected value of 2.32 times and 1.22 times. So during a 12-hour shift, on average, a post-op patient will ring the nurse about 2.32 times with a standard deviation of 1.22 times. That's it for this video. We only have one more in the series. Again, if you have questions, please let me know. I'm here to help you guys out. You can reach me via email or text, or I do have office hours on Tuesday and Thursday that are set aside just for you. And so far, nobody showed up. So please make use of those. Um, I feel a little silly staring at my screen for an hour with no one in there. So if you have questions, that's a great time to drop in. Otherwise, I'll see you in the next video.